Okay, so the next idea, writing an indirect proof by contrapositive. This kind of goes back to our truth tables, right? So we have to remember that the conditional and it's contrapositive, which is negating both the original conclusion or the original hypothesis and conclusion, and flipping them around, right? Reversing them. They are logically equivalent. They have the same truth value. So if you prove the contrapositive, you also prove the conditional, which is pretty powerful. So what we're going to do is we're going to assume that Q is not true, or assume not Q is true. What this is going to lead is it's going to lead to not P, that the hypothesis is not true, which is then going to show that not Q will lead to not P. And this is your contrapositive. If the contrapositive is true, then the conclusion, then the conditional must also be true. And this is the idea. So again, it all hinges on this idea that the conditional and its contrapositive are logically equivalent. Okay. And we did that back when we wrote statements. All right, so let's take a look at this proof here. It says, write an indirect proof of the following statement using proof by contrapositive. It says, for two positive integers and an m, if n times m is greater than 16, then either n or m is greater than 4, or both are greater than 4. So again, this is your conditional. So we're going to assume not Q. Assume, and we're going to use notation here, symbolic notation. Assume that n. So if n is greater than 4, then n must be less than or equal to 4, and m must be less than or equal to 4, right? Because it says either one of them is greater than 4 or both are greater than 4. So the only other possibility is that they're either both equal to or less than 4. Okay. And again, this is negating the conclusion. So what we're going to do here is let's multiply them together. So therefore, if we multiply them together, we're going to get n times m. Let's just write them next to each other, sorry. Right, you don't need the dot there. So nm would be less than or equal to, and 4 times 4 is 16, right? This is the negation of P. This is not P. So we just showed that not Q leads us to not P. And this is that idea of proving the contrapositive true, since not Q if not Q, then not P is true. Then if P, then Q is also true. Which means that this statement is going to be true. So we just restate the statement. Thus, for two positive integers, n and m, if n m is greater than 16, then either n or m is greater than 4, or both are greater than 4. And there you go. And again, how in the world could you prove this directly? There are so many combinations of numbers that if you multiply them together, you get greater than 16, right? That follow this condition. So that's why we do it indirectly. And it takes one statement to lead to the conclusion. All right, good. So again, we're just doing our best here with this indirect proof. All right, great. All right, thanks for watching. And this is the end of topic 1. So coming up is your assessment. Good luck.